So today we're going to look at multiplication and division of rational expressions or functions. All right, so let's have a look. First question is simplify the following and state restrictions. Actually, that's the only question we have. Great. Okay, so let's look at A. So first thing is we're going to determine what our variables are. So variables are D, R, and H. And we're going to multiply. So multiplying rational expressions or functions is very much like multiplying fractions. So that's all we're doing here. We're multiplying fractions. So why don't we do, let's see if we can do this towards the right-hand side. Okay. All right, so I'm just going to rewrite it. Okay. Like this. I find it a little easier when it's like this. So when you multiply fractions, remember what you do? You just multiply the numerators and multiply the denominators. So in the numerator, just multiply everything together. And in the denominator, do the same, multiply everything together. Great. And now we're going to cancel out common factors in the numerator and denominator. So if you notice, there's a 2 that's common, the pi is common, and the r is common. So what are we left with? In the numerator, I'm going to scroll over a little bit, we're left with dh over, and then in the denominator, d minus 2. So now we need to state restrictions. So remember, the restrictions are when the denominator equals 0. So from our simplified expression, it looks like our denominator is just d minus 2. Unfortunately, that is not the complete denominator. So just stating that d equals 2 as a restriction is not sufficient. We need to go back to before we simplified. So that's the previous step. And if you noticed in the previous step, we have r times d minus 2. So 2 and pi are constants, but r, d, and h are variables. So we need to consider when r equals 0 or when d minus 2 equals 0. So we've taken into account when d minus 2 equals 0. So the other time the denominator might equal 0 is when r equals 0. So these are our restrictions. Therefore, the restrictions are when d equals 2 or, let's put that in there, be very explicit, or when r equals 0. All right, so now let's look at the second one. Let's look at B. All right, so we'll do that one to the left. 4z squared minus 25 over 2z squared minus 13z plus 20 times z minus 4 over 4z plus 10. All right, so let's rewrite it. Why don't we quickly rewrite it? So our variable z, and we only have one variable, and it looks like we're going to have to factor times z minus 4 over 4z plus 10. All right. Okay. Well, that's kind of messy. All right. Okay. So let's start with the first rational function. So 4z squared minus 25. So if you notice, that's actually a difference of square. 4z squared is a square and 25 is a square, so we can factor that. So remember how to factor a difference of squares. All right. Now let's look at the denominator, 2z squared minus 13z plus 20. So I'm going to assume we can factor that, and we'll figure it out. Okay. All right, let's start with the 2z squared there. Only factors of 2 are 2 and 1, so we're stuck with 2z and z. Now the 20, so the factors of 20 are 1 and 20, 2 and 10, 5 and 4, so we need to use those factors, or some set of one pair of those factors, and see if we can get our cross term, the negative 13z. All right, so if we use 5 and 4, I don't think it's going to work. Right? That's not going to work. So let's try. So why doesn't it work? So if we use 5, 4, and 5, like for example this, so 2z times negative 5 is going to give us negative 10. Then negative 4 times z is going to give us negative 4. That's going to give us negative 14z as our cross term, which is not what we're looking for. So let's try something else. Let's try 2 and 10. I'm wondering if that even factors now. Let's have a look. 10 and 2. So we're kind of stuck with the same situation, aren't we? We do 10 and 2. That's not good. And 20. 20 and 1. All right, so I'm confused now. So I'm going to take the liberty of changing our question there. So I'm going to change it so it factors nicely. Yeah. 2z squared minus 14z plus 20. Let's try that. Normally you can't do this on a test. You can't really change the question, but this is on a test, so I'm going to change it just for demonstration purposes. All right, let's see. What do we have here? Actually, I think it does work. My mistake. Okay, let's do this. All right. Let's try that. Let's see if that doesn't work. All right, I'm making a mess of this, but this is okay. Mistakes are good. Let's check this. All right, so we have 2z minus 5 times z minus 4. Let's see if this works. All right, so 2z times z is 2z squared. 2z minus 4 is negative 8z minus 5z plus 20. Well, negative 8z minus 5z is negative 13z. So we managed to factor it. So I'm going to go back and change it to 13. Okay, so it works. All right, so now let's look at this second rational function. So we have z minus 4 in the numerator, which is good. Over, we can factor out a 2 in the denominator. So we have 2 times z plus 5. That's interesting. All right, now equals. So remember when we multiply fractions, we just multiply the numerators and we put it over the product of the denominator. So we can just do that. So now let's look for common factors in the numerator and denominator. So the first one I see is a 2z plus 5. And I have written that incorrectly. Well, we're noticing a lot of mistakes that I'm making, which is good because we're finding the mistakes, and that's what you want to learn how to do when you're doing the exercises on your own. So the 2z plus 5 cancel out, so let's cancel that out. What else cancels out? Oh, the 2z minus 5, so we have one of those, that cancels out as well. And look at that, z minus 4 also cancels out. So what are we left with? In the numerator, we're left with 1. So 1 times 1 times 1 is 1. In the denominator, we're left with 1 times 1 times 2, which is 2. So we're left with a half. So that's our answer for when we simplify. Now we need to state restrictions. All right, so remember the restrictions are when the denominator equals 0. So in this case, it looks like our denominator is 2, and 2 is not equal to 0. However, we need to go to the previous step where we've factored. And when we look at our factor denominator, we see that we have 2z minus 5, so that may equal 0, or z minus 4 could equal 0, or 2z plus 5. Why don't we put that on the next line? Or 2z plus 5 may equal 0. So this means, therefore, z equals 5 over 2 or 4, or when z equals negative 5 over 2. These are our restrictions. So when z equals 5 over 2, 4, or negative 5 over 2. Good. All right, so one more. So this one's a division. Good, something different. Okay, whoops. All right, so we have x minus 5 over x plus 3 divided by x plus 1 over x minus 2. So remember, with division of fractions, the division of fractions is actually a multiplication, but the first term, yes, yeah, I'm trying to remember the name. It's a divisor. Yeah. Anyway, the first part, this, we leave as is. And then when we do a division of a fraction, we actually multiply by the reciprocal of the divisor. So in this case, the reciprocal is x minus, we just switch the numerator and denominator. There. So now it's a multiplication. We know how to do that. So we might need to do a few more division worked examples. So now let's multiply them together. So we multiply the numerators and over the product of the denominators. And can we simplify? No, not really. It's simplified. Okay. So let's state restrictions. So this is quite interesting. All right, so to state restrictions, remember the restrictions are when the denominator equals 0 for any of the rational expressions or functions. So in this case, there's actually 3. There is the x minus 5 over x plus 3, so there's a denominator there. There is the x plus 1 over x minus 2, so there's another denominator. And then when we took the reciprocal, we have x minus 2 over x plus 1, we have yet another denominator. So we actually have 3 denominators. Even though it looks like after we simplified and did the division and simplified, it looks like we only have 2 denominators, but that's not the case. So if we look at our 3 denominators, let's put it over here. Our restrictions are when any of these equals 0. So therefore x equals negative 3, 2, or negative 1. So those are the restrictions. Good. And we're done.